Hey everyone, Brandon Lee here with Virtualization How To, and today we're diving into a topic that may ruffle a few feathers, but I think it's something that we all need to consider as we move forward in the tech world. Why hypervisors don't matter as much. So stick with me, and by the end of the video, I think we're going to cover some practical insights to help guide us in the home lab as well as production infrastructure and the tools that we all rely on. So let's dive in and get started. First, let's address the elephant in the room, the VMware and Broadcom situation. The licensing changes, updates to vMUG, and the uncertainty around VMware's future has caused a lot of home lab enthusiasts as well as organizations to hit pause on their VMware strategies and reevaluate their configurations. But don't worry, I'm not going to spend the bulk of this video talking about that. We've covered that a lot this past year in 2024. Instead, I want to use this as a jumping off point for something that I feel is even bigger. Why the focus on hypervisors is becoming less critical. And I think as we come to terms with that, it's going to help us move forward in not only the home lab and self-hosting, but also in production environments. So let's rewind a bit. In the past, we were laser focused on which hypervisor we were running. VMware, Hyper-V, Proxmox, KVM. They were all critical decisions because virtual machines were the backbone of basically everything. But now there's been this total shift, and we've seen this over the past few years with cloud native technologies. And even in home labs now, containerized technologies like Docker and Kubernetes, they are becoming the standard. And the beauty of containers is this simple fact. They are hypervisor agnostic. Now, there are hypervisor specific technologies such as VMware Tanzu or others, but in general, that's a fair statement. Now, we all know this. You can run containers anywhere, on premises, in the cloud, or even across multiple clouds. And this portability is a game changer because it means that we're no longer really chained to one hypervisor or infrastructure. So I want to give you guys a practical look at what I'm talking about when I say that we're not as tied to the hypervisor when we're looking at containers. I want to show you guys one of my Proxmox hosts here that I have an environment set up just for this reason to explain this. As you can see, I've got a K3s node running on Proxmox here. Now, this is just K3s Kubernetes distribution running on top of Ubuntu 24.04. Here is the cool thing though. As you can see, I've got it running in Proxmox. I also have the second and third node running inside of VMware ESXi. Now, for many of you, this is no surprise, but it helps to illustrate the fact that when we're talking about Kubernetes, when we're talking about Docker, it doesn't care what that underlying hypervisor is. I can have nodes spread across Proxmox, VMware ESXi. If I had a KVM host stood up, I could have one of those nodes running in KVM. They are not even aware of that hypervisor layer underneath. And this is just a case in point. I've got this Kubernetes cluster spread across two different hypervisors, Proxmox and VMware ESXi. So why doesn't the hypervisor matter as much when we're talking about containers? Let's consider a few of the key reasons. First of all, containerization really abstracts the hypervisor layer. Now, the hypervisor is an abstraction from the physical infrastructure, but containerization takes that a step further. Containers run directly on the operating system, meaning that they don't rely on the underlying hypervisor like traditional virtual machines. Kubernetes can orchestrate your workloads no matter what's underneath it, whether that's ESXi, Hyper-V, Proxmox, bare metal, or something else. A second reason is portability across platforms. Unlike virtual machines, containers and Kubernetes pods are built for mobility. You can deploy the same application stack on your local machine in a home lab, or you can deploy it in a public cloud with minimal reconfiguration. Now, what we mean by that is I can log into any container host. This particular host is running in my home lab data center, and I can log in here and I can pull down a container image in a public registry or in a private registry that I have running that's accessible And I can essentially pull down that same application to any container host that I have running anywhere. For instance, I can pull down an Nginx container here in the home lab data center, and I can run this same command in a public cloud container host or in another data center. And even if I have a customized image out on Docker Hub, I can still pull those customizations down to whichever container host that I have running. Now, would it be that easy to simply pull a virtual machine from one location to another? No, it would not be. And you would have to refactor that virtual machine to run if you're running VMware ESXi on-prem, if you're running AWS EC2 in the cloud, if you're running Proxmox in another data center. You would have to refactor that virtual machine to run in that environment. Not the case with containers. Now, we all know with virtual machines, you often have that underlying proprietary disk format that we all have to deal with, so that refactoring from, let's say, VMware to Proxmox to Nutanix to Hyper-V, all of those transitions are really fairly painful when you consider the amount of time, the amount of data that has to be transferred, as well as the network bandwidth, and so on and so forth. But that's simply not the case with containers. They're lightweight, very efficient, and they are essentially an application image that is agnostic, once again, to the hypervisor underneath or the physical hardware that that hypervisor is running on. Another consideration is cost efficiency. With the focus shifting away from licensing and hypervisor specific tools, you can cut costs by leveraging and using those lightweight solutions, bare metal, or even open source platforms like Proxmox and KVM without much disruption. Containers run on all of those hypervisors underneath. Now, here's why you should shift your focus to containerized technologies moving forward. First of all, with containers, if you focus there instead of the hypervisor, you're going to see a tremendous boost in the ease of spinning up applications. If you're like me, have you ever beaten your head against a wall trying to figure out a prerequisite or dependency that wasn't working quite right in a virtual machine? Maybe something like Python versions or other tedious components that were throwing errors. Now, this can be an absolute nightmare with virtual machines. Now, with a container image, all of your prereqs are bundled, and you've got all of those components it needs all right there, taking that major headache out of the equation. So in the home lab, for instance, if you want to try out a new Docker solution, or you want to try out a new DNS solution or something else, you can most likely find that as a container image and literally in seconds have that application up and running without having to spin up a new Linux virtual machine, new Windows virtual machine, and installing components, prerequisites, all of that nasty stuff that we just simply don't want to have to take the time to do. We're well past that. And we have the tools with containers to be able to hit the ground running, so to speak, with those applications. That's what's important. Now, another major win with containers is automation. Tools like Kubernetes offer built-in automation for deployment, for scaling, for updating. Even with Docker, you can do very cool GitOps operation with tools like Portainer, and even using custom CI/CD environments. Also, we think about cross-platform compatibility. The same workload can run seamlessly on your home lab server, public cloud, or edge devices. So if you decide to move from VMware or Proxmox to an EC2 instance, no problem. If you decide to go from the cloud back to on-premises with a container, no problem. Now, as long as you're running Linux in the cloud, if you're running Linux on-premises, you can do all of those things seamlessly. And the same goes for Windows containers. Also, DevOps integration is much stronger with containers. Containerized applications offer modern CI/CD pipelines. You can deploy, you can automate, you can trigger. All of those things that would be extremely painful with virtual machines, you can do easily with containers. Now, for all of my home labbers out there, this doesn't mean that you should go out and rip out your hypervisors tomorrow after you watch this video. They still have their place, especially if you're running legacy workloads. And you will always need a virtual machine underneath to run your container host, at least for the foreseeable future. But the point is this: don't get stuck debating whether to use VMware, Hyper-V, or Proxmox. Instead, invest your time learning containerized technologies. Tools like Docker, Kubernetes, Docker Swarm, and even lightweight alternatives like MicroK8s or K3s are the future, in my opinion, and will make your life so much easier. Here are some practical steps that you can take to start this journey into a more modernized approach that's not really focused on the hypervisor, but more focused on containerized applications running in Docker or Kubernetes. First of all, I would recommend start experimenting with Docker if you've not already. Start small by containerizing one of your existing applications. I'm a really firm believer in real world projects. For instance, if you're running a Pi-hole server on a Raspberry Pi device or in a virtual machine, migrate this to a container, and you'll be surprised at just how much you'll learn on a single project like that. And I know that was how I started. I just picked an application I had running in a full virtual machine and said, how do I containerize this? Also, learn Kubernetes basics. Set up a Kubernetes cluster in your home lab using something like MicroK8s or even Minikube. These tools allow you to play around with single node Kubernetes clusters, and that makes it super easy to get started. You don't even have to start with a 3-node cluster or even larger. You can start with a single node. Next, explore hybrid environments. Try running containers on different platforms to see really how easy it is to move them around from one container host to another and even to an EC2 instance running in the cloud. Also, I definitely recommend focusing on DevOps tools. Learn how to integrate CI/CD workflows into your containerized setup. Now, this may be a later step especially if you're starting out with the basics, but I guarantee you that this shift will not only future-proof your skills, but it's also going to make your infrastructure more flexible and cost-effective, not only in production, but also home labs. I have seen a significant reduction in resources since I have containerized most of my applications. I'm fully running on mini PCs and very lightweight storage, and I plan on keeping it that way. Also, just a note, I plan on showcasing some of these very practical projects in upcoming videos that hopefully helps walk you through some of these very cool projects and how they are not really as complicated as you might think to go from a full virtual machine to running inside a container with your self-hosted applications. Now, in wrapping up this discussion, hypervisors will always have their place, but as the world moves toward containerized and cloud native technologies, the role of the hypervisor is becoming more like the foundation of a house. It's very important, but it's not the focus of what you're doing every single day. Now, let me know in the comments, are you already working with containers, or is this a new area that you're ready to explore? And don't forget to like, subscribe, and share this video if you found it helpful. Also, if you get stuck on a project, visit the Virtualization How-To forums. Create a forum topic out there, and myself and many other community members will be able to jump in and help you through whatever challenge you're trying to work on in the home lab. Well, once again, I'm Brandon Lee. I hope you enjoyed the video. Please do stay safe out there, keep on home labbing, and I'll see you in the next one.